Today, we're going to walk through questions across the Year 8 curriculum as you prepare for your end-of-year exam. So, where my Year 8s at? Where my Year 8s at? Come Year 8s, let's go! Where my Year 8s at? Where my Year 8s at? Come Year 8s, let's go! Welcome back, my BBN family. Yes, we are brilliant by numbers. This video is part 1 of a 2-part revision series. In this particular video, we are focused on paper 1, which is your non-calculator paper. Also, while I know this video is a little bit lengthy, I cannot stress it enough the importance of watching it all the way through, as I've taken the time to revise the objectives that you've covered throughout the year. However, watching it through doesn't mean watching it all in one sitting. But it's important to get all the way through to the end, as I've carefully tailored this so that you will be helped to maximize your results in terms of the marks you score on the papers. So, like I've said before the intro, where my Year 8s at? Where my Year 8s at? Let's go Year 8, let's go! Now, before we get started in the actual questions, there are a few tips I want to talk you through. The first of which is reading the questions. Now, when you get into your exam, you need to ensure that you read the question twice. If you have the time, you can go ahead and read it 3 times. Next, underline or highlight important information. What is the question asking? So you need to ask yourself, what is this question asking? What does the answer look like? Now, you need to work through the question. Do not just think about the answer in your mind or the steps in your mind and then put the answer down. No, you need to work through the question in a clear, logical way. And then you should ask yourself, have I answered the question I was asked? Very, very important. Then, for example, if a question says you should estimate, you should not do the actual calculation. Make sure you round your numbers to one significant figure. That's what it means to estimate. The second tip is a little bit more detail about your working out. So, tip number 1, you must show your working out on the spaces provided for each question. Try to make your work very organized. Next one, a wrong answer with no working gains no marks at all. However, if you have a wrong answer, but you had correct steps on your way to that answer, you can gain as much as 2 out of 3 or 3 out of 4 marks. Yes, you heard me right. So make sure that all the questions that you do, you show all the working out. Final tip here is about diagrams. Now, if you get diagrams on your paper, always make sure that you observe that the questions say not drawn to scale. If they want you to measure, they will tell you use a protractor to measure this angle, for example. But do not assume that all questions are already drawn to scale. So, almost all diagrams are not drawn to scale, so they are not drawn accurately. And do not measure angles or lines unless the question specifically asks you to do this. If you do that without that being said to you, you are likely to be incorrect, and we are not after incorrect answers at all. I hope that you found those tips useful. Now, Final thing we'll talk about, and then we get started, is your equipment. It is quite essential that you are prepared. It really does take away all the anxieties from you and give you that smooth, calm, settled start to your paper. So make sure you've got your ruler marked out in centimeters or millimeters. Make sure you've got a protractor, because you're doing pie charts, for example, you will need to measure accurately all the angles. You need a sharp pencil, so you could be asked to draw a linear graph, for example. You need to have a nice sharp pencil so that you can make that smooth line along. We need to also have a compass, but maybe just for this exam you may not need one, but come prepared nonetheless. And make sure it's a formal examination, your end of year. Make sure you have a black pen, and also take a spare. What if the one you have run out? You always have another one. And if you're doing your calculator paper, you will need a calculator that you know how to manipulate. Do not just come and say, oh, I don't have a calculator. Be prepared at all times. Beautiful. Now that we've laid all of that foundation there, we are ready to start our revision. Beautiful. So the first questions we look at is solving equations, and this is very, very important because equation comes up in other topics other than algebra. Could be doing your geometry and you have to employ the skills of solving equations. So we're going to tackle that first of all. So here we are asked to solve 3x minus 5 equal to 16. A very good way to approach these questions is, first of all, to look at the operations that we are given. And then we look at the inverse of those operations. So I'm just going to go ahead for the first question. I'm going to draw a little table, and I'm going to write what I have in the question for my operations and what I need to do for the inverse. So I can see here I have a minus 5. That tells me I will need to do a plus 5. I also have a multiplication by 3. So I write that down. I'm going to then need to do a division by 3. I've laid my foundation. Now I'm going to tackle them one at a time. So I'm just going to rewrite the question here. So 3x minus 5 is equal to 16. I know I need to do add 5, so I'm going to add 5 to both sides of my equation. So a negative and a positive 5 cancels out to 0. So on the left hand side I have 3x left, and then I need to do 16 plus 5, which is 21. I'm going to tick that off. I've done my addition. Next, I need to do my division by 3. So I'm going to divide both sides by 3. So 3x divided by 3 will just give me 1x, which we can just write as x. And then 21 divided by 3 is equal to 7. So x is equal to 7. That clear, logical thought will help you to process your information in a clear way. Now I can also test my answer if it's true. So if x is equal to 7, then when I multiply 3 times 7, which gives me 21, and take 5 away, the answer should be 16. And that's how I know I'm correct. Awesome. So we're going to apply the same principles to the other questions on the screen. So I go ahead and I'm going to write what I have and what I need to do. So here I have a plus 6. I'm going to need to take away 6. I also have a multiplication by 4. So I'm going to need to also divide by 4. Now that I've laid that out, one at a time. So I'm rewriting my question, take it out of the working, put it onto my working space. So I go ahead and I need to subtract 6 from both sides. This left hand side will leave me with 4y, And 26 take away 6 gives me 20. I tick that off. I've done my subtraction. Now I simply need to do my division by 4. So therefore, y would be equal to 20 divided by 4 gives me 5. Beautiful. I then go on to the other question. I'm going to write what I have and also what I need to do. So here I have a subtract 1. I know I'm going to need to add 1 to both sides. I also have a multiplication by 3. I'm going to need to divide by 3. Awesome. So I go ahead, rewrite my question. 3w minus 1 equal to 14. I need to add 1 to both sides. So this side will now result in 3w, and that's equal to 14 add 1 gives me 15. I check that off. I've completed that step. Now I need to divide both sides by 3. So 3w divided by 3 just gives me w. I could just look at it like cancelling out these 3. And then 15 divided by 3 gives me 5. And remember, you can do your rough check. Now for the next question, we're asked to solve 2a minus 8 equal 12. I go ahead, I write what I have in the question and what I need to do. So I have a minus 8. And then I'm going to need to add 8. I also have a multiplication by 2, so I will also need to divide by 2. I'm going to go ahead and I'm going to write my question out again. And then I will start by adding 8 to both sides. So add 8, add 8. We know a positive and a negative 8 cancels out to 0, so 2a is equal to 12 add 8 is 20, and then I've checked that off. I now need to divide by 2. So a is equal to half 20 is 10, and there I've got it. Clear logical thought. So now we're going to go along and we're going to look at some questions that involves brackets. A very beautiful opportunity to help you to remember how to expand your brackets. So before we solve these equations, we first of all have to remove the bracket by expanding. So we are asked here to solve 5 bracket a add 3 equal to 20. So my first step, I'm going to rewrite my question. And then I'm going to, before writing what I have and what I need to do, this time I need to expand my bracket first. So I go 5 times by a gives me 5a, and 5 times by 3 gives me 15. And that's equal to 20. Now, a very common mistake that students make on these questions, they forget that they need to expand both the numbers in the bracket. So some people will have multiplied 5 times a, but forgot to do 5 times 3. That will not be you. So now that we've got this, we're now going to do what we have and what we need to do. So here we've got a plus 15. We're going to need to do a subtract 15. Then we've got a multiplication by 5. We're going to need to do division by 5. So we're going to go ahead and we're going to take away 15 from both sides. So here I've got 5a left. And then 20 take away 15, that gets me 5. I check that off, completed. Now I need to go ahead and I need to divide both sides by 5. So we've got a left on that side, and then 5 divided by itself goes once. So the answer is a is equal to 1. Beautiful. Now we're going to go to do the second question. Here we've got 6 bracket d minus 2 is equal to 1. So we know we have to expand our bracket first. So we go rewrite our question. Notice I always do that. I want to distinguish my working out different from the question given. So I need to go for 6 times D gets me 6D. At this point, you need to make sure you say 6 times minus 2. That helps you to think about the fact that you're multiplying a positive times a negative, which gets you a negative. So this will give me minus 12. That's equal to 1. I'm now going to write what I have and what I need to do. So I have a minus 12. I will need to do a plus 12. Then I've got a multiplication by 6. I need to divide by 6. So we go ahead and do our add 12 on both sides. So we are left on this side with 6D, and then 12 plus 1 is 13. So I check that off. I now need to divide by 6. So dividing by 6, I will get D on its own, and I can leave my answer as 13/6 unless the question told me specifically to give my answer as a decimal. Now remember, this is a non-calculator paper. It is much safer to leave your answer as a simplified fraction, so I'm going to leave my answer as 13/6 for this question. I go on to my next question, which is also expansion. So I'm going to rewrite my question. So G plus 7, and that's equal to 66. So I go ahead and I expand my bracket. So 11 times G gives me 11G, and 11 times 7 gives me 77. Now that's equal to 66. I go ahead and write what I have and what I need to do. By now, the number of times I've said this, I am sure that when you get into that exam, you will remember, what do I have? What do I need to do? That very clear logical step, and also that repetition is also good for you. So I know that I have a plus 77. I'm going to need to do subtract 77. I have multiply by 11. I'm going to need to divide by 11. So let's go. We need to minus 77 from both sides. So I've got 11G, and that's equal to, notice here I'm taking a large number from a small number, so I will have a negative answer. So 77 take away 66 is 11, but now the other way around will give me negative 11. So I'm checking off the fact I've done my subtraction. Last step, I need to divide both sides by 11. So I will have on this side, left hand side, will be G equal to a negative divided by a positive is a negative. So the answer is -1. And remember, you could always go ahead, substitute back, check to see if this is correct. Final one is a little bit different, as you can see. So this time we have a bracket, but we also have a term outside of the bracket. Now we need to remember to use BIDMAS. So what does BIDMAS say? Brackets first. So we're going to take care of our bracket first, and then we can work along with whatever was outside of the bracket. So I'm going to go ahead and I'm going to rewrite the question. So 5 bracket P add 2. Outside my bracket, I have 2P equal to 38. So we're going to go ahead and expand our bracket. So 5 times P gets us 5P, and 5 times 2 gets us 10. Then we've got our 2P equal 38. I can see here that 5P and 2P are like terms. Remember, we can only add the variables together, but we cannot add a variable and a number. So 5P plus 2P gets us 7P. So 7P add 10 equal 38. Now we will write what we have and what we need to do. So we have a plus 10. We are going to need to do a minus 10. And we have a multiplication by 7. We're going to need to divide by 7. So we go ahead and we subtract 10 from both sides. So here I've got 7p equal to 38 take away 10. That is equal to 28. And then what we need to do, check that off. We now need to divide by 7 on both sides. So p is equal to 28 divided by 7 gives us 4. You can see here on a non-calculator paper, it's very important to know your timetable. I cannot stress that enough. Now, before we move along, I know that you're finding this video useful. So please just take 1 second and give the video a like. This helps to build our community because it helps the YouTube algorithm to share with new viewers, and that's what we want. So thank you for playing a part in growing this channel. Now that I've said that and you've done that, let's move on to the next questions. Okay, so this time we're going to do the last of our equations, because this time we're doing equations involving fractions. Now, the same principle applies. We look at the question. First one says, solve 2x divided by 3 equal to 4. So we're going to write down what we have in the question and what we need to do. So you can see here 3 is being divided into 2x. So we have a division by 3, which means we need to multiply by 3. Then we also have at the numerator here a multiplication. So we're going to multiply by 2. We need to divide by 2. So let's take our first step by multiplying by 3. So I'm going to rewrite, as I always do, my question. 2x divided by 3 equal to 4. I need to multiply both sides by 3. Now the left hand side will cancel out. By dividing by 3, I get 2x equal to 4 times 3 gives me 12. So I'm going to check that off. I've done my multiplication by 3. I now need to go ahead and do my division by 2. So therefore, x is equal to half 12 is 6. Operation successfully completed. We go on to our next question. This time we're asked to solve a divided by 2 plus 1 equal to 7. So we go ahead, we're going to write what we have in the question and what we need to do. So here I have a plus 1, so I write that down. I'm going to need to do subtraction of 1. I also have a division by 2, so this time we got our division first. Then we'll need to multiply by 2. So I go ahead, rewrite my question. Plus 1 equals 7. I go ahead and I subtract 1 from both sides. So now I'm left with a halves equal to 7 take away 1 gives me 6. I check that off. Now I need to multiply by 2. So I'm going to do multiply by 2 on that side and also on that side. So this side will cancel out, leaving me with a equal to 6 times 2 is 12. Beautiful. And there goes for my answer. Now I've got the same kind of principles here. Operations have changed, but principle remains the same. Amazing. So here I have solve p divided by 3, take away 3 equal to 2. I'm going to write what I have in the question and what I need to do. So I have a minus 3. I'm going to need to add 3. Also, I have a division by 3 I'm going to need to multiply by 3. I go ahead, I'm going to rewrite my question. So rewrite my question, then I'm going to apply my principles. So I need to add 3 first to both sides. So this will leave me with p thirds equal to 5. 2 add 3 is 5. I check that off. Now I need to multiply both sides by 3. So this 3 cancels out. So p therefore is equal to 3 times 5, which is 15. So let's do a quick rough check for that one. If I substitute 15 for p, then 15 divided by 3 is 5. 5 take away 3 gets me back to 2, and that's how I know I'm correct. Awesome. Final one, let's write what we have and what we need to do. So I have a plus 10. I'm going to need to take away 10. And then also I have a division by 5. So that means I'm going to need to multiply by 5. What do you notice? I also have a multiplication by 4. So I'm expecting that I need to also divide by 4 at some point. So let's go. So I'm going to rewrite my question. 4y fifths plus 10 equals 16. So we go ahead, we do the first one, which is subtract 10 from both sides. So that leaves me with 4y fifths equal to 16 take away 10 is 6. So I'm going to go ahead, check that off. Next, I need to multiply by 5. So multiply by 5, multiply by 5. So this cancels out, leaving me with 4y equal to 6 times 5 is 30. So I go ahead, check that off. Last step is to divide by 4. So I'm going to divide by 4. I'm going to put my answer here. So this cancels out, leaving me with y equal to 30 divided by 4. Now, if you're not great at dividing with the highest common factor, you could also have just halved first. If you see what number goes in, 2 goes into 30 and also into 4. So I can go ahead and half 30 and half 4 and make the answer smaller. So half 30 is 15 and half of 4 is 2. It's so much easier now to half 15. So half of 15 is 7.5. So my final answer is that y is equal to 7.5, which is the same as 15 halves. Amazing. So we've gotten through our series of revising the different ways our equations could be presented. Amazing. And remember, you can always go back and look back through the questions, pause the video, try the questions yourself, and then come back to see, did I get these questions right? Beautiful. So we're moving on. So we're going to now be practicing our linear graphs. Now, linear graphs is one that comes up in almost every year group. I've done the year 9 walkthrough. They've got linear graphs. The year 10s, the year 11s working on linear graphs. So it's a strong concept that is likely to be tested in almost every exam, regardless of the year group. So we've got to make sure that we are good with our graphs. So linear graphs. So the first concept I want to remind you of here is the general equation for a straight line. So the general equation for any straight line is always y equal mx plus c. Now, m is our gradient, and that tells us how steep our line is, and c is our y-intercept, and that tells us where our straight line crosses over the y-axis. Now, a very important note here is that the bigger your gradient, the steeper the line. I'll say that again. The bigger your gradient, the steeper the line. So let's say, for example, I had two lines, y equal 3x plus 5, and also y equal 5x plus 4. I observe my gradient is always where m is. So the gradient of the first line is 3. The gradient of the second line is 5. It means that the second line has a steeper gradient. The line is going to be steeper because the gradient is the biggest one. So if I'm asked which line is steeper, I look at my gradient. Remember, gradient tells the steepness of the line. Awesome. Now that we've laid that down, we're going to move on to some questions on linear graphs. Now, before you approach any question on linear graph asking you about your gradient or your y-intercept, always make sure your equation is written in the form y equal mx plus c. Do not go ahead and just write it down. Check that the line is in the correct form first. With that being said, we'll read our first question. So, we're asked here to write down. So I'm going to underline that, write down. This means my answer is already on the paper, looking at me, waiting for me to identify it. So write down the coordinates of the y-intercept of the line y equal 2x minus 3. Question, is this in the form y equal mx plus c? And the answer is yes. So I go for my y-intercept. So if I look here, my y-intercept is minus 3. Do not forget the sign. Now the coordinate means I need to have a value for x and also where the line will cross the y-axis. So whenever the line crosses the y-axis, x will always be 0. So the x coordinate then will be 0 and the y coordinate will be minus 3. So I know my y-intercept, x will always be 0. So 1 mark there. Part B asks me to write down the gradient. So again, write down gradient of the line. So we just explored that our gradient is always the one before x. You could see that in the formula. So therefore, the coefficient of x here is 2. So m for the gradient is equal to positive 2. Awesome. Very simple. Mark there. 2 marks. We go on. Next question asks us to do the same. Write down the coordinates of the y-intercept of the line y equal 8 minus 5x. Question, is this equation in the form y equal mx plus c? I could say yes as a teacher, but as a student, I will say always make sure that your x term comes first, and that helps to eliminate inaccuracy. So we're going to rewrite this one. So I'm going to write y equal to, I'm going to put my x term first. I'm going to rewrite it with minus 5x. I have to recognize that this 8 is positive, so positive 8. Now I can freely write my gradient down and also my y-intercept. So they've asked me here, write down coordinates of the y-intercept. Now it's very clear to see that my intercept is positive 8, and remember, x will always be 0. So the answer is 0, 8. Beautiful. Now the next question asks me to write down the gradient. It's easier because I've rearranged it here to see my gradient is the coefficient of x, which is minus 5. So m equal minus 5. Do not forget your sign. Beautiful. Another 2 marks scored there. Moving along. Next one asks me here can see the progression of the questions. Write down the coordinates of the y-intercept of the line to y equal 5x plus 6. Question, is this in the form y equal mx plus c? And the answer is no, because we cannot have 2y. We need to have y. So I'm going to rewrite this here. 2y equal 5x plus 6. So my first step here is to get y on its own. So to do that, I can do division by 2. If I divide all of the equation by 2, I will now get y to be on its own. So let's go. So divide by 2, divide by 2, divide by 2. 2y divided by 2 gets me y on its own. I now have 5 halves x, but 5 halves is also written as 2.5 if I convert that. It's okay if you left it as 5 halves. And then 6 divided by 2 is 3. So now the equation is now in its correct form. Now is when I go for writing what I was asked. So we need the coordinate of the y-intercept. Now the intercept here is 3. So x coordinate 0, 3. Beautiful. You can see how far that has come from 6 all the way to 3. So next one asks me to write down the gradient. Now because I have rearranged the equation, I will now get my gradient. I can see my gradient is what is the coefficient of x, so m then is equal to 2.5. And like I said, if you said 5 halves, that's okay. Now another progression here for 2 marks. Question being asked here, is the point 2,8 on the line 2y equal 5x plus 6? I know you will be tempted to just go ahead and make a conclusion, say yes or no, but here the question helps you out. It says you must show your working. Now, even if the question doesn't say that, you must show your working. So let's go. So first of all, I have to test to see if this point is on the line. First of all, what I need to do is to substitute the points given here for x and y. So I'm going to label, the first one is always x, the second one is always y. Beautiful. Now, if I substitute x and y in this equation, both sides should be equal. If it is equal, then yes, this point is on the line. So when I substitute x, if I get the corresponding y value in the bracket, then that's true. If not, it's not on the line at all. So let's go. Because we rearranged this one already, we're going to substitute in the rearranged version. So y equal to 2.5x plus 3. So I'm going to substitute the x value in, and when I do that, I'm expecting to get the y value, which is 8. So let's go. Y equal to 2.5. I'm going to replace the x here with the value of x, which is 2. When I work this out, if I get the y value to be 8 as well, then this is correct. So what is 2.5 times 2? 2.5 plus 2.5 is 5. So y then is equal to 5 add 3. Y is equal to 8. Yes, we have proven it. Here, y was also 8. Now, I cannot just stop there. I need to answer intelligently. You were asked if it is on the line. Now we're going to say, therefore, 2,8 is on the line. So is on the line. y equal 5x add 6. So you make an intelligent answer. Tell your examiner, yes, it's on the line. Or if it was no, it's not. Beautiful. So now we're going to a little bit further where we are introduced now to our graph. Beautiful. So we're given this straight line graph. We're told here is a straight line graph. And how do I know this? Because I see a straight line. Part A, write down the coordinates of the y-intercept. So you can see, you could get it from a word, you could get it from the graph as well. So now I need to remember that in the introduction we talked about the fact that the y-intercept is where the straight line crosses the y-axis. So I go to my graph and I look. I can see it touches the line, the y-axis, right at +2. Now this is where you visualize what I said before, that x is always 0 when this happens. So we can see here x is 0, so 0, 2. So my answer is 0, 2. So that is my coordinate. Now remember, if the question had just said write down the y-intercept, you would just write 2. But if it says the coordinates, you must have x and y. Very important. Now the question doesn't say write down the gradient this time. It says work out, and we're doing that from the graph. So remember, to find the gradient of a line from the graph, we must make a right angle triangle, a perfect right angle triangle. This means we cannot have like half of a square, we must have full squares. So another thing to do is to observe the scale of the graph. I can see here that this graph is going up in increments of 1. Perfect. The other scale on the y-axis also going up in 1. So it's okay to count the squares. If it's not going up in ones, we need to count the units and not the squares. So I'm going to find a place on this triangle where I can just make it perfect. So if I go from this perfect spot here, intersection, I'm going to go to another intersection. So therefore, I guarantee I will have perfect squares. Make your triangle now. So on the y, remember, gradient is equal to y divided by x. So on the y, I've got 1, 2 squares along. So y is equal to 2. And on the x, I've got 1, 2 squares along, so x is equal to 2. So therefore, 2 divided by 2 is equal to 1. So the gradient is equal to 1. 2 marks. Beautiful. Now, a follow-up question says, use your answers to part A and B to write down the equation of the line. Very kind question says, give your answer in the form y equal mx plus c. So I need to know my gradient and also my y-intercept and then put them all together. So let's go. Y equal, my gradient is 1. So I'm just going to write 1x and my y-intercept is 2. But we know that in algebra, we don't need to say 1x. We can just go ahead and say y equal x add 2. I can also check to see if I'm correct. All I need to do is to take a point. If I take x to be 1, I expect that 1 plus 2 is 3. So I go up on my graph and I check, is that 3? Yes, it is. So I know my equation is correct. Beautiful. You see the different ways the question can be posed to you? We go on now where we are given 2 lines intersecting on the graph. And they've asked us, they've said line L1 and line L2 are shown on the grid. Work out the equation of line 1. And for part B, 3 marks this time, also ask us to work out the equation of line 2. And you may wonder, why 2 of the same questions? Beautiful opportunity for me to remind you about the orientation of your lines and how these influence your gradient. So for line 1, as I look on, I realize that because it is sloped from right to left, line 1 is going to have a positive gradient. Very important here. So I'm going to write that down. Line 2, however, is sloped from left to right. So that one will have a negative gradient. Lots of people will just run along, make their triangle and draw this up without paying attention to that. So now I've given myself that focus. I'm going to find the gradient first of all of line 1. Then I'm going to write down its y-intercept and then put them together. 3 marks for that equation. So remember, y equal mx plus c. So I need the gradient and I need the y-intercept. And when I've got them, I'll put them together for my equation. So let's go. So I'm going to, first of all, easiest one to do is to write down my y-intercept. So c is positive 4. Gradient, let's draw our perfect triangle. So I'm going to draw it from here. So gradient m y over x on y, 1, 2, 3 down and 1 across for x. So 3 divided by 1 is equal to 3. I can now write my equation down. So the answer is y equal to, the gradient is 3, so 3x. The y-intercept is 4, so add 4. Finish with that question. Move along to get my gradient and y-intercept of the negative one. So I need to write, let's write our c down as well. So c for this one, where does the line cross the y-axis? Right here at -2. Beautiful. Now I need to find my gradient, which is y over x. So I'm going to find a space. I could do from -4 here and go to -4 as well. So go across, make a perfect triangle. Now this time, because I'm coming from the top, remember when we go down, it's going to be minus. So 1, 2, so that's -2 for y, put that in. And then I've got 1, 2, 3, 4, but I'm going to the right, so that's positive. And then I can simplify this to give me negative 2 into itself once, and 2 into 4 goes 2. So I've got my gradient. Finally, y equal, gradient is -1/2 x, and my y-intercept is -2. And there we have it. We have completed some questions from our words. We've completed it from the graphs. We've experienced negative gradients. We've experienced positive gradients. I am absolutely proud of you as you prepare to smash that exam. Awesome. So now let's go into another question on linear graphs. We're almost there with linear graphs, but I've made sure to take the time to help you to prepare for this, because I know lots of students do not love graphs at all, but as I said before, they are always coming up. So I wanted to just take the time to help you to navigate this and different ways in which your question could come. So if you look at this one, it says work out, again, we can't just write down this time, work out the gradient of the straight line through 2, 8, 5, 20. So this time we've got to use the formula for a gradient of a line from 2 points. So the gradient of a line from 2 points, the formula is y2 take away y1 divided by x2 take away x1. So x1, y1, x2, y2 are the starting and ending points of these 2 points we are given. So we go ahead, first of all, we label x1, y1, x2, y2. So remember, the first pair is the ones, the second pair is the twos. You cannot mix them up. So now that we've labeled them, we're now going to substitute them into the formula. So y2 is 20. So 20 take away y1 in our formula here is 8 divided by x2 is 5. Take away x1, which is 2. We're going to now simplify this. So 20 take away 8 is 12. Count your fingers if you have to, but on a non-calculator paper, do not mess this up. Then we need to do 5 take away 2, which is 3. So our gradient then, m, is equal to 12 divided by 3 is 4. 2 marks. Make sure that you remember this formula if you are asked to do a question where you're finding the gradient from 2 points. Now, a straight line has gradient 4, so write that out, m equal 4, and passes through the point 3, 10. Work out the equation of the line. Give your answer in the form y equal mx plus c. Now remember, 2 things we need to write down the equation of a line. We need the gradient, which we were given, but we now need the y-intercept. So how to do this 3 marks question? We need to first of all write out the formula and substitute what we know. So y equal mx add c. I know the gradient, so I can put that in. So y equal m is 4, so 4x plus c. Now, to get the y-intercept, I need to substitute the point I was given. So the first one is 3, and that's the x-coordinate. And the second one is 10, and that's the y-coordinate. So I'm going to substitute that for y and x, and then I can find the c value. So y is 10, so 10 for y is equal to 4 times by the x value is 3, and then plus c. See that? All we have now is just one letter, and we know when we've got just one letter, we can find the value of that letter. So we go ahead and we do 4 times 3 is 12. 12 add c. And we did equations before, so now we know how to solve this. We need to say what we have. We have a positive 12. So we're going to need to take away 12. So let's go minus 12 from both sides. Remember? 10 take away 12, we are doing a small take away a large, so that's minus 2. 12 minus 12 is 0, so we're only left with c. So c is minus 2. So now I know the gradient is 4, and I know the y-intercept is 2. I can write the equation of this line. So y equal to gradient is 4. So 4x, and the y-intercept is minus 2. And there I have it. Let me fix this 2. It looks like a z, but it's 2. So it's minus 2. So y equal 4x minus 2. Awesome, amazing. So the last step we need to take to conclude the section on linear graphs is to actually draw some lines that were given on the graph, and also complete our tables of values, and then draw the line for ourselves. So let's go off to do that. So the first one is about horizontal and vertical lines. Very important vocabulary there. So we're asked to plot and label the lines. The first one we're asked to do is y equal 1. So remember, we go for our y-axis and we look where we have positive 1. So I'm just going to put a mark there. Remember, when we have a value equal to y, we are going to have an horizontal line. So I've pre-drawn that in. You will take your ruler and your pencil and draw a nice line through it, and then label y equal 1, so your examiner knows which line matches with which equation. So we tick that off. Now we are also asked to draw y equal minus 3. So we look on the y-axis and we look for minus 3. Beautiful. And then we take our ruler and pencil, draw that line in, and label y equal minus 3. So by now, I think you figured it out. If I'm going to draw x equal 2, that's going to be a vertical line. Beautiful. So I go to my x-axis, they're labeled for you. I find positive 2, but this time it's going to be a vertical line passing through, and then I label x equal to 2. Tick that off. Now I need to draw x equal minus 4. So I go on my x-axis, identify my minus 4, take my pencil and my ruler, and I draw that line in, label x minus 4. Not bad at all. We go to our final question now. We are given a table of values, and we're asked to complete the table of values for y equal 2x plus 4. Two values have been already put in for us, and then I'm going to tell you a little secret after we work out the values. So all I need to do here is to substitute my x values in the equation where x is, and then that will tell me my y value. So y equal to 2, where x is, I'm now going to replace it with minus 1, and then I need to add the 4. So y will be equal to 2 times minus 1 is minus 2, add 4. So this is where a lot of people mix it up. Remember, I have 4 things, I give away 2, I will have 2 left. So this is the same as 4 take away 2, which is 2. I put that on my table, closing my gaps. I go ahead for 1, and I'm going to do the same. So y equal to 2, bracket, instead of x, I'm now going to put 1. So that will be equal to, sorry about that, 1, add 4. So y is equal to 2. 2 times 1 is 2, plus 4, that gives me 6. You notice here, there is a pattern. So it's very good to look for pattern. I've got 2, 4, 6, gap, then 10. So I know the next missing one is going to be 8. So I could do that. Now, the secret is, what if you had forgotten how to substitute? You could have just plotted the 2 that they gave you, which was 0, 4, and 3, 10, and then extend the line. The line will then pass through the coordinates for the missing ones, and then you could just write it from the graph. Thank me later. Okay, so now the part B asks us, on the grid, draw the graph y equal 2x plus 4 for values of x from minus 1 to 3. Sounds complicated, but basically what they're saying, draw the values that you did on the table. So we're going to plot them. Before we plot, it's very important to observe the scale of the graph. If you notice here, the y-axis is going up in 2s. The x-axis, however, is going up in 1s. That means halfway between 0 and 1 is a half. Very important observation there. So I'm going to go for minus 1 to positive 2. Remember, we do our x coordinates first, followed by the y. So I need to go to minus 1 on x and then go up to 2 on y. Plot a point, check that off. Then I need to do 0, 4. Remember, 0, 4 is dead on the y-axis. Beautiful. So we then go for 1 to 6. Let me check that off. 1, 6 is here. Then I go for 2, 8. 2 to 8 is here. And then 3 to 10 is all the way here. Now we know if we do not get a straight line, something is wrong. This is linear graphs. So I've pre-put that in. Always label y equal 2x add 4. From here, you should have noticed the y-intercept is 4 and its coordinate is 0, 4. The gradient is 2. Beautiful. So now we have put the whole set of linear graphs together. It doesn't matter what question should come up on linear graphs. I know you've got this. So How about you just type it in the comment section now and let me know how you feel about this revision. By now, your confidence should be boosted and ready for this exam. You know, we're going to go through all of this. I know it can be a little bit challenging, you know, just to sit down and revise when you want to play with your friends. But if you do this well and you do it well once, you won't have to do it again. Can you imagine? I've said that a lot to the students who are doing even their external exams. You have to sacrifice for your education, guys. So as I said, comment, let me know how you feel about this revision as you prepare for that paper. I feel confident for you. Let's go. So now we're moving from the graphs. Now we're going to sequences. Yes. So first one, notice the language here. A linear sequence starts with 3, 6, 9, 12. See, linear sequence, there is a relationship between the graphs we did and the topic sequences. Now, if we should plot our linear sequence on a graph, it will produce a straight line as well. Awesome. So we're asked here to work out an expression for the nth term, underline, of this sequence. Now remember, your nth term is your general rule that governs this sequence. So when we had before y equal mx plus c, that's the format for the nth term of the graph. So when we found the gradient and when we found the y-intercept, what we have really found is the nth term of that graph that makes it true for all points on the graph. So that's what we're doing. So we're going to rewrite 3, 6, 9, 12. Remember, to find the nth term, we need to find the difference between the terms. So to get from 3 to 6, we're adding 3. 6 to 9, we're adding 3. 9 to 12, we're adding 3. Remember, the formula is the difference multiplied by n. So 3 times n is 3n. And remember, we always look for our zero term. So what would have been the term before the 3? We can get that by doing 3 take away 3, which gives us 0. That means if I should put 3n plus 0, it's still going to produce 3n. So in this series, the nth term is just 3n. Now guys, test it to see if it's true. When n is 1, 1 times by 3 gives me 3, so I know that's correct. When n is 2, 2 times 3 gets me 6, so I know it's correct. Beautiful, always test. So we move to the other question. A linear sequence starts with 50, 56, 62, 68. Work out an expression for the nth term. Again, we need to find our difference first of all. So 56, 62, 68, we're going up by positive 6, positive 6, positive 6. So remember, 6 times n gives me 6n. Now I need to find what would be the term that came before, the zero term that came before 50. So to do that, I need to do 50 take away the 6 here. 50 take away 6 is 44. So that means it's positive 44. My nth term is 6n plus 44. Brilliant. And that was 4 marks for both questions. So on we go. Now a linear sequence starts with 2, 6, 10, 14, 18. This time the context of the question has changed. It now asks me to work out the 100th term of this sequence. And this is 3 marks. What does that mean? Clearly, we can't sit down and multiply the numbers or add the numbers all the way up to the 100th term. That will take the whole exam to do. So what we need to do here is, first of all, find the nth term. And then when we found that, we're going to substitute 100. So let's go. So we'll find our difference here. To get from 4 to 6, we are adding 4 each time. So we know that's going to be 4 times n, which is 4n. I now need to find my 0 term. So I need to do 2 take away 4. So let me visualize that for you. So 2 take away 4 gives me minus 2. So the nth term is 4n minus 2. Now that I've done that, I need to find out what is the 100th term. It means then that n would be 100. So I'm going to substitute the 100th term would be equal to 4 times by 100 take away 2. So 4 times 100 is 400, take away 2 is 398, and that's my answer. Amazing 3 marker there. Beautiful. So let's just tick that off quickly. Now another question says a linear sequence starts 4, 7, 10, 13, 16. This question is different now. Is the number 91 in the sequence? Tick one box. So now we're testing, is a number in the sequence? And show working to support your answer. Now, again, what we need to do is to find our nth term. But this is going to link back to the equations we solved when we were revising equation at the beginning. So what we have to do is when we find the nth term, we now need to make it equal to 91. If it is that we solve the equation and I get a whole number for my answer, then yes, this number is in the sequence. However, if I solve it and I get a decimal, it is not in the sequence because terms are whole numbers. So for example, term 1, term 2, term 3, term 4, term 5. I cannot have term 2.5. That's not a thing at all. So let's go. We're going to find the nth term. So let's look. We're going here. We're going up by 3. Going up by 3. So we know we need to do 3 times n, which is 3n. Then we need to find our 0 term. So 4 take away 3 gives us 1. So it's going to be 3n add 1 for the nth term. So what we need to do now is to make the nth term equal to 91 and work it out to find the value of n. So 3n plus 1 equal 91. Remember, to solve our equation, I write what I have, what I need to do. See, another brilliant opportunity to revise that. So I have a plus 1, I need to minus 1. I have a multiplication by 3, I need to divide by 3. So let's go. Minus 1 minus 1. This cancels out to 3n. 3n is equal to 90 take away 1 is 90. Check that off. I now need to divide by 3. So 3n divided by 3 is just n, and 90 divided by 3 is 30. So the answer is a whole number. So yes, 91 is in the sequence, but don't just stop there. Tell your examiner it is the 30th term. Amazing. Very good. This one, I suggest you watch it again because it's easy to forget how to prove if the number is in the sequence. So just rewind, watch this again. Okay? Amazing. All right, so we're going to move right along. Giving me a little trouble here to move on to the next slide for some reason. All right, let me just do it from here. Okay, so the third and fourth terms of a geometric progression, notice the language here. First one was linear. Now this is a geometric progression shown below. So underline geometric progression. Now we're given 12, 24, but we're not given the first and the second term. The question asks us to work out the first term. So my first logical line of thought here has to be, what is a geometric progression? So remember, in a geometric progression, each term is being multiplied or it could be divided by the same number. So for example, if I'm multiplying the first term by 2, I also have to multiply the second term by 2, and so on. If it's division, the same principle applies. Now, because we are asked to do the first term, we have to go in reverse. I know 12 and 24, so I'm going to go backwards. I need to see what can I do to 24 to get to 12, and that is dividing by 2. So we go ahead, 24 divided by 2 gives me 12. I now need to do 12 divided by 2, which gets me 6. I then need to do 6 divided by 2, which gets me 3. So let me put my 6 here, and then 6 divided by 2 gives me 3. So clearly, the first term is equal to, so let's write it, first term equal to 3. And I can check, 3 times 2 is 6, 6 times 2 is 12, 12 times 2, 24. That's how I know I'm correct. Beautiful. Next question says, the first 2 terms of a geometric progression are 8 and 16. Work out the 4th term. Beautiful. So to do that, I need to do 16 divided by 8 to get what I'm going up by. Lots of you will say, I can see I'm multiplying by 2. So 8 times 2 is 16. I now need to do 16 times by 2. So double 16, that's 32. And then I need to do 32 times 2. Double 32 gets me 64. So we write intelligently, 4th term is equal to 64. Amazing. Beautiful. So we've done linear and we also done our geometric progression. Okay, so moving along, we go to percentage multipliers. So here we're asked to match the following percentages with their multipliers for 3 marks. Clearly, if we get maybe 2 wrong, we will get 1 mark. So for this question, we need to be dead on accurate so we can get the 3 marks. So the first one is 1.25. Then we got 0.25, 0.75, 0.04, and 0.4. On the matching side, I've got a decrease of 25%, 25% of a number, 4% of a number, increase of 25%, and a decrease of 60%. We are going to go one at a time. So I've got 1.25. If I should write this as a percentage, we would need to multiply by 100, which will give us 125. So we can see clearly that this is an increase from 100 by 25%. So for the first one, it will just be matching there. So that's an increase of 25%. For the next one, we could say that one is just 25% of a number, and that's exactly what it is. But it could also have been if the option was here. Remember, when we do decrease percentage, we always take away from 100. What's left will indicate to us, was this a decrease? So if it was a decrease, this would have been a decrease of 75%, which means that we're left now with only 25. But guess what? That's not an option here. So the only option that could work for that one, since that's an option, is that that one is 25% of a number. So when you get your calculator paper, if you wanted to find 25% of a number, you could have just multiplied by 0.25. The next one is 0.75. That could indicate 75% of a number, but we look in our option, it's not there. So the only other option is to do 100 take away 75, which means we're left with 25. So this one has to be a decrease of 25%. So if we decrease something by 25%, we are left with 75%, which can be written as 0.75. Next option is 0.04. We look at our options on the right hand side. The only thing that it could be is 4% of a number. So we put that in. And then the final option, even though it's the last option, we still read it. So 0.4, it could be 40% of a number, but that's not the option. So that means it is 60% decrease. So remember, 100 take away 4% gets us to 60, and also the other way around. So if we decrease something by 60%, we would only have 40% left. Amazing. I'm so proud of you guys. I am so proud of you. You are taking the time to do your revision, and I'm happy that you've also stayed with me. And remember now, share the video with someone just in case they haven't heard that the year 8 revision is out. Please, let's not just keep it to ourselves. Help me to get other people to benefit as well. Now we're going to move on to percentage increase and decrease. So let's read our first question. So all students at the school were asked if they wanted a new school uniform. Here is some information about their responses. So we can see here, yes is 36%, no, we don't know how many said no, unsure was 17%. Part A asks us what percentage of students said no. Nice and simple question here, because we know that percentage is always out of 100. So all we need to do for this question is to add the ones we were given and subtract from 100, and there we would have our answer. So we know no is going to be equal to 100% take away the sum of 36% plus 17%. Now, this is a non-calculator paper. Do not just do it in your head. Set it up by the column method. So we're going to do 36 add 17, and then we'll subtract from 100. So 6 plus 7, 6 plus 6 is 12, plus the extra 1 gives us 13. And then 3 plus 2 gives us 5, so we know this is 53. So basically, we're subtracting 100, take away 53. Again, I'm not taking it for granted. I'm just going to do 100%, take away 53. So I'm going to take 1 from here, leaving me with 9. So 10 take away 3 is 7. And 9 take away 5 is 4. So my answer is 47%. Well done for doing that. Now, part B said 600 students attend the school. Work out how many students said yes. So we go back to the diagram. Here we're told 36% said yes. So what we need to do is to work out 36%. So we need 36% of 600. Now again, this is non-calculator, so we can break down our 36 into tens and to 1%, and then work it out and then add them all up. So first of all, I'm going to do 10%. So we know 10% of a number is dividing the number by 10. So 10% then, 600 divided by 10 is 60. So clearly I can find 30% by multiplying that by 3. So 6 times 3 is 18, and we've got 0, which will be 180 altogether. Now we need to work out our 1%, and we're going to need 6 of those 1% to get us the 6%. So let's first of all work out what is 1%. So 1% of 600, remember 1% means dividing by 100. So 600 divided by 100 gets me to 6. So 1% is 6. I need 6%. So what I need to do is to find 6% of 600. I need to times that 6 by 6, which gets me to 36. So now I have 30% and I have 6%. I now need to just add them together. So final answer would be 180 plus 36. See, I'm doing my column method just for accuracy. So 0 plus 6 is 6. 8 plus 3, that's 11. And then bring 1 to the other column. So my answer is 216 students said yes. See, I always answer the question intelligently, not just writing numbers down, but making my conclusion to what I was asked. Beautiful. Moving along. Next question says a gym has 2,500 members. I underlined that, give myself a focus. 70% of the gym's members visited the gym last month. How many members visited the gym last month? So this question is asking me to find 70% of 2,500. So I know my reference point is always 10%. So let's find 10% first, and we're going to need 7 lots of 10%. So 10% of 2,500, again, we're dividing by 10. So this is going to be 250. Now I need 70% altogether. So to get from 10 to 70, I multiply by 7. So therefore, I'm going to need to multiply 250 also by 7. So let's set it up, column method, before we put our answer. So 250 multiplied by 7. So again, timetable, very important here. 7 times 0 is 0. 7 times 5 is 35. We bring our 3 over. 7 times 2 is 14. 14 add 3 is 17. So the answer is 1,750. I'm going to make my conclusion. So 1,750 members visited the gym. GYM. How fancy my letters are. Okay, so that's how we answer that question. So we find a breaking point. 10% is easy to find by dividing by 10, and then we scale up by multiplying by 7. Beautiful. Okay, so now we're going to move to another question. This time we are doing a decrease. So we're asked here to decrease 18,000 by 6%. So again, what would you say is your reference point as a percentage? It is better to find 1% this time, and then we need to find what is 6% by multiplying by 6. But remember, this time we are decreasing. Do not forget to subtract after you have done your calculation. So let's go ahead and first of all find what is 1%. Remember, 1% is dividing by 100. So I need to do 18,000 divided by 100. For this one, I can cancel my zeros off. 2 from the bottom, 2 from the top. So 1% is 180. So what I need to do now is to multiply that 180 by 6. So 6% is equal to 180 times by 6. So 6 times 0 is 0. 6 times 8 is 48, and I bring my 4 over. 6 times 1 is 6 plus 4 is 10. So 1,080 is the decrease. So now I need to subtract that from the total. So write that down, column method. I line up my digits properly. Notice I start from my ones column just to make sure I've put the digit in the right order. Now I go ahead and I do my subtraction. 0 take away 0 is 0. I can see I have no number here. In the tens place is 0, 0. So I need to go all the way over to the thousands column. Taking 1 from 8, leaving 7. I'm bringing 1 here, taking 1, leaving 9, and I'm putting 1 here. So 10 take away 8 is 2. 0 from 9 still leaves 9. 7 take away 1 is 6, and nothing take away from 1 And so I've got 16,920 for my answer. So the answer is 16920. Beautiful. Next question says, Kayla buys a car that normally costs $18,750. She received a 20% discount. How much will she pay for the car? Nice red car there. So, first of all, I need to find what is 20% of the total number given, and then because it's a discount, I have to subtract, just like I done in the first one. This is nice and calm because I'm doing 20%, so now I can find 10% first, and then I will double that, and then remember to subtract it from the original. So let's go. I'm going to do 10% of 18750. Remember, we are dividing this by 10, so 10% then will be 1875. Now I need to double this for my 20%, so I'm going to either multiply by 2 or just add it onto itself. So I'm going to choose multiplication, so times by 2. So 5 times 2 is 10, bring 1 to the next column. 7 times 2, 14, plus 1, 15, bring 1 to the next column. 2 times 8 is 16, plus 1, 17, bring 1 to the next column. 2 times 1 is 2, plus 1 is 3. So that represents her discount. So now I need to find my final answer by doing the original, take away the discount. So total will be equal to 18750. Take away, again, line up properly your digits in the right place value column. So 0 take away from 0 is 0. 5 take away 5 is 0. 7 take away 7 is 0. 8 take away 3 is 5. And nothing take away from 1 is 1. So she is going to pay 15,000. So answer equal to 15,000 pounds. Beautiful. So remember, use your column method a lot, and that's because you don't want to do calculation in your mind and make simple errors. Okay, off we go for another question. So this time we're going to do reverse percentage. Now we're told here that this beautiful lamp that we see is on sale, and it's on sale at £22.05. This is a 10% reduction, so we underline that, of the normal price. What was the price of the lamp before the reduction? So very important note here is that this £22.05 represents 90% because 10% was taken off. So we write that first of all. So I'm going to write that this £22.05 is equal to 90%. Beautiful. So what I want is what was the 100% before this reduction. So what I can do is work from 90 to find what is 10% first of all. I can see here, to get from 90 to 10%, I need to divide by 9. That means I also need to divide by 9 on the other side. But I'm going to set this up in my column method to make it easier for me to navigate. So I'm just going to do that working here. So 22.05, I'm now going to divide by 9. So again, timetable, very important here. So how many 9s are in 22? What's the closest number on your 9 times table? So I can see 3 9s is 27, too large. So it has to be 2 times. 2 times 9 is 18. So I now need to have 4 remainder. 9 times 2 is 18. 19, 20, 21, 22, 4. Use your fingers if you have to. So I put that 4 here. So now I need to do 9. I've got a decimal here. So 9 into 40 closest number to 40 on my 9 times table is 6. So I put that value there. Or did I say 6? So, sorry, it is 9 times 5 is 45. So we have to go 9 times 4. So 4 nines is 36. And then we will have 4 nines 36. That means we have 4 for our remainder. So 5 goes exactly into 45. So 5 times 9 is 45. So 9 into 45 goes 5 times. So therefore, 9 divided into 22.05 is 2.45. And that would be 10%. But remember, we do not want 10%, we want the total 100. So now I need to scale up from 10 to 100. I need to do that by multiplying by 10. So also on the other side, I need to times by 10. So this means I'm going to go one place to the right here. So that would be £24.50. That was the original price. Now, how do I know I was correct? The original price has to be more than the reduction price. So I can see here I've got £24.50 when I had 22.05 before. Beautiful. So that's how I kind of have an idea. I didn't really make a mistake, and I can always go back to check as well. So next question says Jacob buys a watch costing £84. This cost includes VAT at a rate of 20%. How much is the watch without VAT? So again, I'm thinking, I know the original percentage is 100. Now, if he paid 20% VAT, it means that the price also includes that 20%. So now the total cost will be 120% altogether. Therefore, in this case, £84 represent 120%. And I'm after the original, which is 100%. So how can I get to 10% from, so 10% reference point, if I divide 120 by 12, I will get to 10%. So that means I need to also divide 84 by 12. So 12 times 7 is 84. So that means £7 is worth 10%. Now I can get from 10 to 100 by multiplying by 10. So I also need to multiply my £7 by 10. So 10 times 7 is 70. So that means 100% would be 70. So the cost without VAT, the answer is £70. And for the first one, I just write that there, £24.50 original. Remember, your answer line is very important. So after all your working, transfer the final answer to your answer line. Beautiful. Now we're going to take a look at 2 pie charts question. However, make sure you have your protractor, because for pie charts, you need to measure your angles accurately. Also, you need a sharp pencil so you can mark off your angles properly. And also, you would need to use your ruler to draw that line on the circle as you put your angles in. Beautiful. So, we're told here that 60 students were surveyed about their favorite drink. We're asked to draw a pie chart to show this information. So favorite drink, cola, water, lemonade, orange juice, and black currants. Which one is your favorite? You can let me know that in the comment section. I'm interested to know what you love as well. So cola was 10, water was 20, lemonade was 10, and 15 orange juice, black currant was 5. Now, the first thing we need to do here is to find out how many people will be represented by 1 degree, or how many degrees will need to represent a person. So normally, if you were not told how many people were in the survey, you would have had to count them all along yourself. But the question specifically told us it was 60 people altogether. So I know that all the drink together is equal to 60. So what I need to do now is to divide 360 by 60 so I can find out how much will be represented for one person. So 360 divided by 60 is 6. So 6 degrees will be used to measure for one person. So I just want to make sure you know what you're doing. So I could do 360 divided by 60. Cancel zeros off by dividing by 10. 36 divided by 6 is 6. So that's how I got this 6 degrees. Now, most of the time your table will be given for you. If not, just go ahead, use a nice little space on your sheet to work out the angle that you should draw for each. So I'm just going to put my frequency in that I was given there just to make my work neat and tidy. Now, because I knew that one person was represented by 6 degrees, I can now find out the total for 10 by doing 10 multiplied by 6, which gives me 60 degrees. So I will need to draw a 60 degrees angle for that one. Then I need to do 20 times by 6. 6 times 2 is 12, so 20 times by 6 has to be 120 degrees. Then I need to do 10 times by 6, so I got 60 there. This one is also 60. Then I need to do 15 times by 6. Now, I can use my column method to do that. So 6 times 5 is 30. So I put my 0 down, bring my 3 over. 6 times 1 is 6 plus 3 is 9, so that's 90. And then finally, 5 times by 6 gives me 30. Now, do not just go ahead and draw. You need to check that all the angles you've got add to 360 degrees because the angles in a circle add to 360. So quick check here. I've got 120 here. I can see 60 plus 60 is also 120. So 120 plus 120 gets me to 240. Then I've got 90 plus 30, which is 120. 120 plus that 240 gives me 360. So I know my calculations were correct. So I've just put that in there. Check it equal to 360. Now, for the most part, you will already be given a circle, and most times you're also given a radius for your starting point. But if you were not given that radius, just draw a radius in for yourself from the center. Now it's time for us to use our protractor to measure our angles. So the first one we're going to do is 60 degrees. So here is how you approach this. You take your protractor, you're going to ensure that the baseline of your protractor is on the radius that was given or you have drawn. Make sure the center of your protractor is dead on at the end of the line for the radius. Now, paying attention to the scale. I can see here that it is the outer scale that's on 0. Very important there. So I'm going to go around, all the way around, and mark off my 60 degrees. I think I had pre-put that mark there. So 60 degrees is there. Now I need my ruler and my pencil. So I'm going to remove my protractor now. I'm going to line up my ruler with the line I marked on the outside and make a straight line. Line doesn't need to project outside of the circle at all. So that I know is my 60 degrees. Now, because I'm doing them clockwise, I can go back and label them. If you choose to label before, as you go along, that's perfect. So we drew our 60 degrees. Now it's time for our 120. It's very important here to note that the line you have just drawn is the radius that you're now going to use to measure 120. So I take my protractor, make sure it is on the center, and I need to make sure that the baseline is on that line that I just drew. So again, I'm using the outer scale. So from outside, I'm looking for 120, which is here. I also pre-put that in. So now I move my protractor, and then from the center, I'm going to make that line. Beautiful. So that's 120. Now I could also still use my protractor to draw the other 60. So let's mark off what we've done already so we are not confused. So for 60, because the angle here was also 60, the first one, we could just line up this line and connect it to the circle. That would also be 60. You can see they are the same size. Beautiful. Tick that off. Now I need to do my 90 degrees. We know 90 degrees will form a right angle, but we can still use our protractor to do that. So I'm going to put my protractor back at the center, mark, this time it's the outer scale because I am working from the 0. So my 90 is projected there. Move my protractor, make that line. I have now recognized that the small bit that's left has to be my 30. Now that I've done that, I need to label my sectors. Your teacher, your examiner needs to know which part represents which drink. So we put our labels in. We've got cola, water, lemonade, orange juice, and blackcurrant. You could also put your degrees in to show your teacher what you did. So 120 for water. Then I've got 60 for lemonade. It was 90 for orange juice. And blackcurrant was 30 degrees. Now, in the comment section, let me know how you feel about drawing a pie chart. Okay, then we're going to do another example just to embed that concept. Remember, writing something in the comment section and liking the video is your way, cost-free, of helping to build this channel by sharing it with other persons. And as I said before, the YouTube algorithm will recognize your engagement and also share it with others as well. And that's what we want to happen. Beautiful. So let's go to another question on the pie chart. So Chloe surveyed 120 people about their pets. Draw a pie chart to show this. So first thing here, focus question, how many degrees for one person? We need to find that out first of all. So I've pre-put this in, and we've also pre-put the calculations as well. So we need to first of all do 360 divided by 120 to find out for one person. So if we strike the zeros off here, it's clear to see we're now doing, so this is dividing by 10, 360 divided by 12 will give us 3. So one person is 3 degrees. So since we know that, let's go 30 times 3 gives us 90 degrees. 50 times 3 gets us 150 degrees. 25 times 3 is 75. 15 times 3 is 45. And then we need to check that they all add up to 360. Beautiful. So now that we have our angles we need to draw, we need to get our equipment. Let's get our protractor. So remember, we put our protractor, this one is 90 degrees, so you don't have to use your protractor. You could just draw a line straight across. That's 90. We label that for the cat. So now we're going to use our protractor. So for 90, you don't have to use the protractor. Just make a straight line across. Beautiful. So 150, we're going to line up our protractor on the line we drew across. Make sure the center is dead on at the end of the radius. Then we need to check our scale. So we can see here 0 is the outer scale. So we need to measure 150, which is all the way around. So put a mark there and then remove your protractor, connect that with the mark, and that's the dogs. So then we need to take our protractor again, put it back on the center. Make sure we recognize we're also for this one using the outer scale. We need 75. So 70 is here, 75 is halfway between. Remove our protractor, connect the line, and that's the fish. And then for no pets, that's equal to the part that's left, which is 45. Now we can also go ahead and put the degrees in as well. Beautiful. It's that simple. Remember, work your angles out and then use your protractor, pencil, and ruler to draw them accurately. So that's our question there on pie charts. We're still on statistics, so now we're going to look at scatter diagrams. In this question, we're told the value of cars is used in a used car garage recorded below. So the scatter graph shows this information. Another car drives in the garage. It is 4 years old and worth £5,000. Show this information on the scatter graph. So we'll do part A first. Now, before we draw on the scatter diagram, we need to observe the scale. I can see here age is on my x-axis and the value of the car is on the y-axis. I now need to look what we're going up into. I can see here we're going up into 1,000, but each tiny space is 5. So I need to find out how much it is for 1. So I need to do 1,000 divided by 5 to find out what each tiny one is all about representing. So if I do 10 first of all divided by 5, that's 2, and then I've got zeros. So it's 200 each tiny space is worth. That's very important. Now we're asked to show 4 years old car, £5,000. So I go to 4 years and then I go up to 5,000. Make my cross. Beautiful, simple question there. So we tick that off. We got 1 mark to do that. Next question asks us to describe the correlation between the value of the car and the age of the car. So we know when we talk about correlation, we could have a positive correlation, a negative correlation, or no correlation at all. Now we can see here that the marks on our diagram is projected from the left to the right. So therefore, this represents a negative correlation. So the answer is negative correlation. So we can see here that basically the older the car, the lower the value. Okay, if my dots were going across from the right to the left, it would have been a positive correlation. Now, if the dots are scattered all over the graph, then there is no correlation at all. Now, final question. The next car that arrives is 6 years old. Estimate the value of the car. So in order to do this, we need to draw in first of all our line of best fit. Now remember, when we're drawing our line of best fit, as much as possible, we try to get the line in between the values that we have plotted on the graph in an even way. So for example, in this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points. So basically we want 5-ish to be on both sides. Okay, sometimes it's not easy to do that, but I've pre-put my best fit in there. So it's approximately there. We can see there's no better way to do that so that I have a relationship between my x and my y axis there. So that was the best way I could do that line. Now it is from my best fit. This line is going to help me to make my estimate. So I go back. We want to 6 years and we want to estimate its value. So I go and find 6 on my x-axis. I use my ruler and my pencil to draw a line from 6 touching the line of best fit. Now I need to go across from there with another line. Show your examiner how you got this. So you need to physically draw the lines in. Now I'm going to just read my value from the y-axis for the money. Now remember we said we were going up in 200s. So clearly from 3,000 we have 3,002, 3,004, 3,600. So approximately £3,600 will be the cost of a car that's 6 years old. Beautiful. Okay, so that's our question there on our scatter diagram. Moving along, still on statistical data. So now we're going to look at ungrouped frequency tables. The table shows the number of times some students were late to school in 1 week. We are asked first of all to write down, again, language, write down. The value is on the table waiting for me to identify it. The modal number of lates. Remember, our mode is what occurs the most, how often something occurs. Now, if my frequency is what tells me that information. So I can see here 17 is the highest frequency. So the modal number of lates has to be 0. So we put that down. So 0 lates was more frequent, which is really good. Now, part B asks us to work out the mean number of lates per student. Remember, our mean is our total divided by how many there are. So if I wanted to find out the mean score of how students did on their exam, I need to add up the scores of all students in the class, and then I'm going to divide by how many students there are. So the first thing we need to do on our frequency table is to find the total for each number of lates. So remember, we multiply across, so we need to do 0 times 17, which is 0. We then need to do 1 times 5, which is 5. We need to do 2 times 3, which is 6. Then 3 times 2, which is also 6. 4 times 2, which is 8. And then 5 times 1, which is 5. What we need to do now is to add them all up. And then also we need to add our frequency up as well. So let's get the total for both columns. So 5 plus 6, that's 11. 11 add 6, that's equal to 17. 17 added to 5, let's do that one first, is 22. And then add to 8, which is 30. So our total is 30 for all of the lates combined together. Now we need to add up the frequency column. So we've got 17 here plus 5. You can count your fingers, as I said. 17 add 5 is 22. 22 add 3 is 25. 25 add 2 is 27. 27 add 2 is 29. And 1 is also 30. So my mean then is equal to the total divided by the frequency. So that's a total frequency. And then let's put it in numerical form, which is going to be 30 divided by 30. And the answer is 1. So work out the mean number of lates per student. It's 1 late per student. And that's good. That means students are on time. Brilliant. I hope that's you. Okay. Moving along. Now we are on to recipes. I've got a beautiful stuffed turkey here for you. So shown below is a recipe for stuffed turkey. So we look at our recipe. The recipe serves 4 people. So for turkey, we got 500 grams. Red onion, we need 1. Garlic cloves, we need 2. Chestnut mushrooms, we need 150 grams. Spinach, we need 140 grams. And chicken stock, we need 300 milliliters. Now, question. Mary wants to make stuffed turkey for 10 people. How much of each ingredient is needed? And also, we're asked to include the units. Now, I need to recognize, first of all, that this recipe serves 4 people. So now I need to be thinking, how can I get from 4 all the way to 10? Now, because this would have been on a non-calculated paper, which is what we're preparing for, we're going to need to break it apart. So I hope that you notice we could get 2 lots of 4, and then half of 4 would get us to 10. So what we're going to do first is for each ingredient, work them one at a time. So let's go. So for turkey, it's going to write turkey here. We can get 2 lots of 500. So 2 times by 500, 2 times 5 is 10. So that is 2 times 500 is 1,000. And then we need to get half of 500 for the other 2 people. So 2 times 500 gets us for 8 people. Now I need to half that for the other 2 people. So let's get plus 250, which is half of 500. So 0, so this is 1,250, and the unit is grams. We write that on our answer line. So we're finished with our turkey. Now we need to get for red onions. So let's go. Red onions. I can see for 4 people I need 1. So for 8 people I need, so 8 equal to 2 onions. And then for the other 2, I need to half 1, which is 0.5. So it's going to be plus 0.5. So I need 2.5 onions. So 2.5. We take that off. So let's take it off from the question as well. Now we are on to garlic cloves. So for 4 people, I need 2 garlic cloves. So garlic cloves, we will need 2 lots of 2, which is 4. And then I'm going to need half of that, which is 1. So plus 1 will get me 5 altogether. So I need 5. So let's check that again. I need 2 lots of 2s for 8 people. And then I'm going to need 1 for halfway. So that gets us the other 2 people. We take that off and then we go on to chestnut mushrooms. So chestnut, I'm just going to call that CNM for chestnut mushrooms to make it easier. I've got 150 grams for 4. So I need to double that for 8. So 150 times by 2, that is 300. And then I need to half that. So half of 150 is 75. So we need to add that all together. I get 375. We're almost there. Units included. That is grams as well. Then we go for our spinach. So spinach, we need 2 lots of 140. So 140 times by 2, that's equal to 280. And then I need a half of that, which is 140 divided by 2 is 70. So we add this together. 0, 7 plus 7 is 14 plus 1, 15. And then 2 plus 1 is 3. So I need 350, and the unit is grams. So final one, I need my chicken stock. So for my chicken stock, I need 2 lots of 300. So 300 times by 2 is 600. Plus I need a half of 300, which is 150. So we add that all together. I get 700. Let's put the answer here, 750. And the unit is milliliters. Clear, beautiful, logical thought there. And that's what you need to do. Just make a connection. How can I get from 4 to 10? I can double 4 and half 4. That will make 10 for my recipes. Beautiful. Now, if I had the opportunity, I would have asked you to cook the turkey for the 10 people and see if you would have enough turkey to give everyone. Okay, so now we're moving on to estimations. So we're asked to work out an estimate. In the beginning, we talked about an estimate means that we should round all our values to one significant figure. So I've got 58.8. One significant figure would be my 5. So I'm going to rewrite the question. Notice I'm using the symbol for approximation. So how to round? I check the digit behind the 5. I can round up. So this is closest to 60. Multiplied by, first significant figure is 2. So nothing changes with 0 behind. So this is still 20. Divided by, first significant figure here is 1, nothing to round up, so this is 100. So we go ahead, 6 times 2 is 12. I've got 2 zeros here, so 1,200 divided by 100. I can cancel common zeros out. 12 divided by 1, final answer is 12. Beautiful. We go to our next question, another estimation. So here we're asked to estimate the total cost of 31 television. Each television costs £196.50 each. Remember, pay attention to that. And 19 DVD players at £50.99 each. Show clearly how you obtained your answer. So again, we need to round our numbers. So 31 is approximately, if I check, 30. And I'm going to multiply that by the total for the cost for one television. So I'm going to round this to 200. Then I'm dividing that by, so not dividing, multiplying, getting my answer. Then for the 19, that's going to be rounded to 20 times by, this one is going to be 50. So 2 times 3 is 6. I've got 3 zeros there, so that's 6,000 plus. I've got 2 times 5, which is 10, 2 zeros, so that's 1,000. The answer then altogether is £7,000 for my total. Beautiful. I am so excited that you have stayed with me in this process. That means you're interested in passing your exam. Awesome. Okay, so now we are on to estimating roots. So between which two positive integers does the value of square root 32 lie? A good practice here is to visualize it. So we need to focus on the square number that comes before root 32. So remember, we get a square number when we multiply a number by itself. So 5 times 5 is 25. That's the square root that comes before 32. And the square root that comes after is 36. So the square root of 25 is 5 and the square root of 36 is 6. Therefore, we expect the square root of 32 to be in between 5 and 6. Beautiful. So it's somewhere between 5 and 6. So now we're just going to do 2 questions on that, and then we do our final question to wrap up this walkthrough. So we're asked to say between which two positive integer value does the following roots lie. So for first question, we put root 42. We figure out which square number comes before 42 and which one comes after. So if we look at 6 times 6 is 36, 7 times 7 is 49. So 36 would come before 42 and 49 will come after. So therefore, square root of 36 is 6, square root of 49 is 7. So we expect the square root of 42 to be between 6 and 7. So that's how you would answer that question. So it'll be between 6 and 7. Next one is square root of 124. So we need the square number that comes before 124 and the one that comes after. So 11 times 11 is 121, very close to 124. And after that, 12 times 12 is 144. Square root of 121, 11. Square root of 144 is 12. So we expect the square root of 124 to be between 11 and 12. Beautiful. Next we go on to our final question on error intervals. So here we're told the mass of a coin is 8 grams to the nearest gram. Complete the error interval for the mass of the coin. So we need the lower bound and the upper bound. Now because this is to the nearest gram, we then need to add and subtract 0.5, which is halfway of the 10th place. So 8 take away 0.5 is 7.5. And 8 plus 0.5 is 8.5. So that would be our error interval. Last question. The distance between two cities is 900 kilometers to the nearest 100 kilometers. Complete the error interval for the distance. Now, because it's to the nearest 100, just like we half our 10th place, we need to half 100. So 100 divided by 2 is 50. So we need to do 900, take away 50, and 900 plus 50. So the first one gives us 850. We put that here, lower bound, and this one gives us 950, and we put that there. And there we have it for our error intervals. So beautiful. You've come to the end of your revision for your paper 1. It is very important that you subscribe, hit the notification bell so you see when I've uploaded preparation for paper 2. Now it's also important you watch both of the videos because you want to make sure that you have revised all the skills that possibly may be on both papers. Absolutely fantastic. So I know the video is kind of a bit long, and so I must tell you, I'm so proud of you for completing it all the way through. If that's you, put in the comment section and let me know I've watched it all the way through, and also the benefit it had on your confidence as you prepare to smash these exams. I wish you all the very best in your exams, and thank you so much for watching.